Welcome to Slight Reliability, the show where we learn SRE and observability 1 week at a time. I'm Stephen Townsend.
Welcome back to Slight Reliability. I'm Stephen Townsend, and this is the show where we learn about SRE and observability 1 week at a time. Today, Valeska Victoria is back. Hello, how are you?
Hi, I'm doing quite well, thank you. How are you doing?
I'm okay. It's early in the morning, as most of my interviews are, but I'm waking up rapidly. I'm excited for this. So we chatted by the time this comes out a couple of months ago, and we had some unfinished things we didn't get to talk about. So that's why we're chatting today. One of the things I really loved about our first interview is that you were talking about real world experiences and incidents that you'd gone through. And I got feedback from people saying they loved hearing about that. And so we're going to do some more of that today. Does that sound okay with you?
Yes.
So you worked at eBay as a reliability engineer. So tell us about an incident. Tell us a story.
Sure, I'll tell
about
you the story.
something you experienced at eBay.
So there was one postmortem that I had to do when I was on call at one point at eBay, and it was interesting because I had advance warning that this might become an issue, actually. There was an issue where one of the databases was basically about to reach capacity, like the disk was going to be filled. It was at like 99%. And it was a consumer producer situation, basically. And the producer was running for quite a while with the consumer operating at a very, very low rate and sometimes potentially not at all. So that's how the backlog was created initially. And I heard about this because there was like a kind of warning sent out to all the SREs just to like, FYI, there's a problem here. And we kind of joined the bridge and kind of looked at it like, okay. And, the SWE teams, or as at eBay they say, the PD teams, they went to work on it. And I think it was the next day I started my on-call shift. I did give them a little warning. I told them, you should be careful when you're trying to go through this backlog, because if you're going to actually process the data, you want to process it at a reasonable rate. Of course, you don't want to risk the disk actually overflowing, because that would be bad. You wouldn't want a core database to be overflowed, but there's probably a reasonable middle ground. It went in one ear, not the other. And the next day I was on call, and now there was some major incident, and I had to investigate. And what I found was that there were multiple stages basically emanating from the consumer flow that originated basically from the database. The database was a consumer, it's reading from the database. So first of all, the database became basically non-functional because of the number of reads. So that already, considering that it was one of the core databases, that already caused a whole bunch of issues because they didn't listen to me to meter their consumption rate. So that caused a problem. However, there were more problems because the consumer flow was not set up, in that whole infrastructure was not set up to handle anywhere near this throughput. So now every single peg or whatever you want to call it, road stop along the way was starting to fail over in some way. And basically the first few ones aren't directly customer facing. So it took a little bit of time until it built up and kind of like overcapacitated everything to reach a later stage where it was actually noticeable. So then it's the typical thing where you're like, oh, there's something way up here in the stack. Like, what's wrong with this? Why is this a problem? What's happening? And then you have to dig all the way down. And thankfully, I was on call because I remembered what they had told me about this going on. So I looked into it. And it actually was interesting because this continued for a few different days. So I first wrote the basically root cause analysis about the DB backlog and how it needed to be cleared, like I told you. And then there was, of course, the zero throttling. So I tried to work with the SWE team to reduce the burn rate. But this, like I was saying, the cascading impact of the applications was pretty extreme, considering that there were many retry requests basically in the consumer flow that were going back 2 years. So that's why there was so much data in the database. And the thing that was really frustrating is that as I was looking through the logs, everything that was being processed, they were users that, like, I remember at one point, 80% of what was currently being processed at that batch of like a few 100,000 requests, like 80% of them were from one user, and then it was 90%, and then it was 95%. And then I started, as hours were going on, it was starting to be millions of retry requests from the same user, the exact same user. And I realized this must have been some sort of power user. I was able to find, because of course you can get their username and you can find them and their store. And they have a big store and they're selling lots of stuff. So it became pretty clear that 2 years ago, something had happened here. And this user had put in like a insane, inhuman amount of retry requests. It must have been automated. And the big sellers, as we knew, they always have some automated way of managing their store. So it made sense that this would be happening, but the people that were in charge of the consumer flow, they just wanted to purge the database. So they didn't care about the fact that this wasn't necessary. We didn't need to process this anymore. And it was causing impact and server load for no reason. So what basically happened is I had to try to get a hold of them. And that's always the hard part because you have to find the correct team. And oftentimes you get ping ponged around. So I started trying to talk to them and basically got ping ponged around to a few different teams. And basically what I did is I eventually found the correct team and I had to convince them that a lot of these requests are unnecessary. So we have to just get rid of them. We just need to purge them. And eventually they did that and that helped. But still, that didn't actually resolve the incident because basically this is a multi-factor incident now, that there are multiple stages to this. So that solved one problem. But the thing is, this revealed another bug. Actually, the downstream, PD teams were actually mishandling the usernames, and they were doing it in a way that it's really unfortunate because basically they were using the display name instead of the actual username. And for a lot of users, like if your username is like eBay Seller 21, it doesn't make a difference if that's your default display name as well. But if your display name is Valeska space Victoria and your username is Valeska no space Victoria, the system that takes the usernames, because basically there's a whole flow, right? If you have, there's this log and that links to another log, and the logs come from the different microservices and they're passing data all the way through. And the next input requires to know what the username is, because if this user is trying to request something, it's going to go all the way down. And at each stage, they want to know what the username is. So at the very first stage from the database, we were giving the wrong username with the space. And all the downstream couldn't handle the space, so it was creating an error. And I think what must have happened is that in the past, a lot of users must not have had spaces or something like that in their name, and maybe there were, because basically there's always errors happening all the time, but they're small usually. It's like a few percentage points, and then there's something that's like a big error or the top like 5 big errors, and there's some small stuff, right? So probably this didn't happen very often, so it wasn't noticeable. It was never something that was a big thing, and obviously because of this little mishap, the developers didn't pay attention. But now that we're getting 80, 90, 95% of all the hundreds of thousands of requests happening in like literally like 100,000 requests in like an hour or less, mostly from the same user, and that user happened to have a space in their display name, and their display name is being passed into their username, was spreading sort of like a crack in glass. And I stopped it from spreading down this branch, but now it's all going down this other branch. So I had to try to get involved with Sweet Teams. The problem there is that now it had to be a different team, actually multiple teams, because first of all, I had to try to help some of the teams basically understand that they should be doing some validation on the input they're being provided, because the error that we got from this was not very readable. Like it took me probably like an hour or something like that until I figured out what was actually happening. I'm trying to remember what actually it was. I think I literally had to look at like thread dumps and a whole bunch of different logs until I finally figured out that it was actually an invalid username, because like the actual error wasn't being logged. It was just like basically saying that this user is invalid for some reason. Like the user doesn't exist. That's what it was. And it's like, why does it not exist? I know it exists. And it was with the big log file, it's like, and I had to finally like, oh crap, there's a space. That was literally how I found it. Like, and it makes sense why other people didn't notice. But it just like I always try to go through like a fine tooth comb because you have to be really, really meticulous. Then that went on to another day because now the sweet team thought it was the end of it. They thought that, okay, some of the teams are going to have error handling, and then the first team is going to make sure that they don't pass downstream the bad usernames, and then it's going to be fine. So the next day I did another deep dive, another deep dive, which was just on my own volition. Honestly, I was on call anyways. It was kind of quiet at that point, and I just wanted to know what was going on. Issues still persisted, albeit now with valid usernames, but the usernames didn't exist because they didn't put in validation of any kind. So now they weren't passing the display name, they're passing the real username. But still, if we're going through the backlog, and the backlog goes back over 2 years, a lot of those users literally don't exist anymore. They deleted their account. So now these usernames don't exist, and this whole downstream is processing millions and millions of requests that fail because there's no user to apply this request to. It's basically like if you say like change my profile picture and that gets lost in the ether, and then 2 years later after you've like deleted your account and moved to Arkansas, now it tries to do that, that profile doesn't exist anymore. So this was an extremely convoluted like web of causality, but I was able to document, simplify it, the necessary components, present it to the SRE team during postmortem review. With pretty good feedback, I would say, from the team. And I made several recommendations to the different suite teams regarding best practices and expiry, basically for the different user IDs, usernames, because basically if you could use a user ID, because we had them, like they're identical. There's an easy way to get a one-to-one mapping. It's like a hash map from the user ID to username. But if you just use the user ID, it's just as good as a username. There's never going to be an issue with display names or some kind of typo or like, spaces or anything like that. And it also, the way that it worked is that you basically have to make a request to convert the username into a user ID, and then you can make requests about the user. So it just saves a request so that each stage you're saving a request, so it's better. And it makes it more obvious because it's only one hop to check if it's a valid user instead of two. And that makes the whole process easier. Another part of this incident is that a whole bunch of the actual host machines were being over provisioned because the Node.js developers that were working with their application, either backend or front end, they realized that there was something happening to where they weren't getting that much throughput. And they didn't understand all of this because everyone is siloed, right? So they didn't understand what was happening here that I was trying to figure out how to resolve. So what they did is they increased the threads to their application in Kubernetes. Like they just basically assigned more processes, pretty much. And the problem is that started creating its own spiral of issues because I had to go to thread dumps for this because there was some weird political thing about like what information should be included in log files. So sometimes log files were helpful and sometimes they weren't. So you had to often go to thread dumps, which if it's a Node.js application, you have to like basically pause an instance of the application, and it's really annoying. But from that process, and you have to manually do it for every single host machine, which is really annoying. But there was a way to aggregate some of it. And then I was able to notice they're running out of sockets because they over provisioned and they didn't realize that they over provisioned more and more and more and more to try to compensate for something that was not compensatable, to the point that they ran out of sockets on a majority of host machines, which made it impossible for them to accept new connections at all. And then they couldn't understand why this wasn't working. And I talked to them, and their whole thesis was, well, there's some kind of problem. Increasing the thread should provide more resources to it, and so it should work. And I had to explain this whole issue about sockets to them. And then their response was, what's a socket?
Yeah, that's a great story. I've got heaps of stuff that I want to ask about this,
Sure.
or like things that I've thought about. The first one is, like you actually did cover this about seeing that the username. So the first thing you need to be logging things like username. Otherwise, you wouldn't have been able to see that this is a particular user who's causing 80% of these requests. And so, so I'm guessing the logs had what you needed to solve this issue.
They did. It's just that you had to use basically logql to aggregate some of this stuff because the standard way of looking at an individual log is not really helpful when you're talking about hundreds of thousands of requests. And that is basically how I was able to do like a distinct sort of clause and figure out like how many is distinct from this user versus distinct by user ID basically. So how many user IDs and how many like requests each, and then I could figure out that versus like total count. And so it's pretty, it's structured query language basically, but it's logql. So that was pretty convenient in order to basically figure out that it was from the same user. Although practically all that really did was help me identify the issue with the spaces in the username, the issue that the user didn't exist anymore, because after that user went away, another big user came, and that user I couldn't find. So if I couldn't have seen that user and I couldn't have looked myself to see that user doesn't exist anymore, then I wouldn't have necessarily known that. Maybe I would have solved it, but it would have taken longer. So it's valuable that sort of information was present.
The other thing about logs I thought about is you mentioned that there's errors occurring all the time, right? And I've seen this in the past. I've seen systems and applications where there are logs and there will be thousands or at least hundreds of particular errors happening all the time, and the developers will say, yeah, that's just normal, that's just what they do, that's just what happens. And it drives me crazy. Like, if there's thousands of errors happening every day, then there's a reason for those errors, and we must be able to do something about it, or at least mute them by making a config change or something. Because my view is that becomes noise, which maybe makes it harder to identify an actual issue. Do you agree with that?
This is my thought process on this. It's noise, but most of the time what happens is the errors are proportional to impact, usually. Not all the time, but usually. So the general wisdom that we had was that if the top 10 errors that you're seeing in the logs, because we had different web interfaces to view this more easily, right? For like a given application or microservice, you could see what the top 10 issues are. And if they're significantly higher week over week, and like the top N are like the vast majority of the total basically errors that are happening, then you can conclude with a pretty good accuracy basically that one or more of those errors is going to be contributing to the incident if the incident is actually caused by something on this microservice. This is a whole problem though, because this is getting into the observability problem, because it can be hard to pinpoint these things because a lot of times it's coming from downstream anyways. And it is always possible that one of the smaller error things can be a problem, but usually if it's going to be one that's not going to be in like the top 5 or whatever, that's only really going to be like a downstream effect. Because if you're looking at the particular microservice and this microservice is having a problem because there's something wrong with it, then that's going to be like the username thing. So for that microservice, like by far, like several orders of magnitude, biggest error was username invalid or user doesn't exist, or all those for the spaces versus like user ID, that sort of thing, right? Or that other like weird error that was really confusing, and I had to do a deep dive into that. That, I guess what I'm trying to say is that the real problem here is that this issue obviously must have happened before, because there must have been people that had a display name that had a space in it. But I guess noise in terms of resolving the incident in real time at the moment when there's a fire, not necessarily. But in preventing incidents, yes, it becomes noise because you're not sure what is actually what and does it actually matter. And that is the big thing, because a lot of times there can be a kind of mindset that like all you have to do is put out the fire, and if it's not currently causing a fire, or as people would often say, if there is no detectable customer impact, even if there is impact on our end, then it doesn't necessarily matter as much, which in practice often means that it's not usually looked into. I would, however, be a little bit nervous about completely muting an error, though, because if they had muted that username error, I wouldn't have been able to figure out what was going on there. So I guess just in general, I'm wary about anything that reduces observability. But at the same time, we do have to handle cardinality, because if you have very high cardinality information and most of it is not useful, then that just clutters your brain and makes it harder for you to resolve the incident.
Another huge thing I took away from that is that we often talk in SRE about it's about the customer, and about these real-time customer interactions. When there's an asynchronous process, it doesn't work that way. Like, the reason this could queue up for 2 years is because it's not necessarily visible. It's happening behind the scenes. And I think maybe we need a different mindset when we're thinking about, batch jobs, async processes, and making sure that we put the right level of monitoring into track. Are they finishing, and how long is it taking, and what is the success rate? Right up front, and treating that as a different case, because we're not going to have a customer calling out to complain when there's something in the background that's not necessarily directly affecting them.
And the way that we kind of handled that was a new initiative basically with open telemetry, because if you have tracing, that does really help, because you can basically see the entire flow in a much easier to digest way from the user all the way down to the back end, in the most simple way with the whole spans concept and then tracing. The only problem, technically, there's two problems. First problem is, I think this has been resolved by now, but I remember at the time there was an issue with OpenTelemetry tracing for async calls, that they were being basically orphaned as their own span. And that made it a lot harder to trace down anything that was asynchronous, because you basically had to figure out the one-to-one matching. And basically, when you're doing OpenTelemetry, it can create a lot of data. So a lot of times people will choose like typical is like 1%. So like only 1% of the actual invocations at any given call actually get recorded into a structure. But the thing is that it's going to follow it through all the way from span to span until it ends. But if something gets orphaned from an async call, now that is another thing that gets part of the lottery, the 1% lottery. Now that orphaned span might not be included in that 1%. So it might not actually even be possible to figure out what happened with that async call. However, when you can use it properly, it makes it significantly easier to handle these kinds of issues, because it provides a basically one-to-one directional structure instead of the old way where it's like you're looking at a log and that log references another log ID and you have to click there to go to the next one, the next one, the next one, and the next one. And that's a much more drawn-out process, especially when you're considering something like performance, which OpenTelemetry really helps with because it shows milliseconds for each single operation. And that's really where I think that monitoring that sort of thing is a place where you could identify some things that are maybe taking longer than they should. And I'm not sure if that necessarily would have been helpful in this particular instance, but it definitely could have shown some clues that the consumer wasn't working quite well. And I do feel like, to be perfectly frank, though, the PD teams do have to take some degree of responsibility because they did create the infrastructure and they did write the code. As SREs, when you're in an organization that is incredibly complicated with hundreds of microservices and applications and complete different flows, selling and buying and all this kind of stuff, it's really hard to keep on track of what all the thousands of different software engineers are doing individually. So at some point, there has to be, you can have all kinds of different analysis and be like, oh, wait, does this make sense? Is there a one-to-one matching here? But at some point, you also have to seed back some percentage of the responsibility to the software engineers to like test their code.
There's another thing I thought about in your story is that there was just bugs, bugs
Yeah.
that had not been caught a long time ago, which with the consequences of those hadn't been felt until much later.
Yep.
And at the point where it's much more complicated to figure out, because now you've got lots of other things, also interacting with the situation. Yeah. Another thing I you made me think about is the Node.js team who just increased the connection or the thread pool, the connections. That's such a good example of making sure that when there's a problem, that collectively we're making one change at a time, that we're making changes based on evidence and not just going, it's just this to this thing. And it's difficult to do in a complex organization where you might have many different teams who maybe have different reporting structures and don't work in the same division necessarily, to get on the same page and be like, hey, we need to come together and be careful about what we do here. Otherwise, we could just cause more problems. Yeah, that's hard.
And to add on to that, I want to be careful about how I say this. It's important that we have a blame-free root cause analysis, because you don't want people to be scared. Because I've definitely seen it before where people just didn't volunteer that much information because they thought that maybe they were going to get in trouble, and they weren't. It was fine. Nobody was going to be upset with them. And it's kind of like, if you create that, then they give you more information, right? However, I feel like at some point you can't be too loosey-goosey with it, because at the same time, I have to know which team is responsible for this, because they're the team that has to fix it. And it takes time to figure that out. And that is kind of unnecessary. And then in addition to that, it's also a certain thing like, this is what happened. You shouldn't be fired or punished because this happened, because you released a bug in production. That's fine, but please don't do it again. Like, please learn from this. I feel like that's the most important thing as SREs. We can't just fix every single bug that happens all the time. We have to fix entire error modes, right? That's the whole Google SRE book, right? It's like you have to figure out here's an entire way in which things could fail, and let's figure out how to address that. We always address the blame culture. We always address like, oh, what about this database? Or what about if we should use telemetry or Kafka or create a new dashboard with Grafana or, keep an eye out for this kind of incident, or, oh, we should start putting heap dumps and thread dumps into our root cause analysis so we can investigate deeper when we have more time, and on and on, preserve the event state, and that sort of thing. And that's all well and good. But at some point, though, there has to be a thing where it's like, okay, realistically, most of the problems that happen, at least in my experience at eBay, are because people just push bugs. That's realistically what it is. Most of the time, they're bugs that immediately fail. And when you look into it, you saw they did not follow procedure. They did not push to pre-prod. They did not test. They didn't do anything. They pushed it to production on Friday at 5 p.m. and went on vacation for a week, literally several times. This has happened. And everyone gets upset about it. And everyone says this was wrong and they shouldn't have done it this way, but nothing ever actually happens because it's always a different team. It's not the same person, right? There's like hundreds of different teams and they're under all their own different organizations underneath the umbrella of engineering. So it's like, it's not like it's, oh, this one guy never checks his code. It's like, it's a prevailing thing. And when you consider that they have different motivations, it's understandable. Like, I don't want to paint them as villains because they're busy. They're very busy. They have codified sprint plans that are very strict, and they have to deliver their story points on target each sprint reliably. And oftentimes, upper management wants them to produce even more features. I remember one time they were talking about, oh, we got to make sure all the SWEs double their output per month, like double the push, basically, like literally rollout. Like, but there was one discussion that was at all hands where they discussed that we wanted to double the rollouts from the SWE teams. Basically, every month they're like X rollouts to prod, but we wanted it to be 2X. And I remember kind of screaming internally when the CTO said that, but it's kind of like, that's their structure, right? They have to push features because the marketing team and all these other people, and maybe artificial intelligence and statistics and whatever else, have decided that this is going to help them reach their quarterly target or whatever for the company as a whole to have this feature done. And they never account for failure in that calculation. They just say, well, that's what we're paying the SRE team for. Since we've started that team X years ago, we've saved blah, blah, blah amount of money and it's helped with reliability and blah, blah, blah. So we don't have to worry about it anymore. SREs will deal with it. But it's kind of a hard structure. And most of the time when I talk to these SWE teams and I said, there's a bug here, I needed to fix it, or I needed to test things, or please follow procedure, please, please, pretty please. What they always said is, I'm swamped with a whole bunch of work and I have to try to make sure that all my tickets are done on time. And I don't have time to now go back and try to debug this old bug that's been in there forever. That's going to be really complicated. There was one time it took them 10 months to debug something, and they said that they were trying a whole bunch of different things. It was put in like very early on, and they didn't catch it at the time. So now it's like basically part of their core technical debt is that there is something that is just really wrong in their whole structure, which is causing memory leaks. That's a whole different incident.
I just think that if the teams of people who are building the software don't own it in production, then it's never going to be a great situation. As long as you have that separated SRE team who are like, you are now accountable for this thing in production, even though you didn't build it, like that, it's never going to work, because how do you go back and change the fundamental problem which caused it in the first place, which is the process and the culture and the practices and the discipline within the product teams?
Right. And it's also impossible to be able to even solve every bug yourself as an SRE because, first of all, people don't want you to monkey around with their code in some random, team. And there's hundreds and hundreds of, repositories. Like, you see a bug when you're on call, your job is to mitigate it and then file a report and tell the suite team that's relevant, please fix. It's not your job to then, I've tried to do this before, to go in there and try to work on it. And that's complicated because it's like, there's all sorts of moving parts and you're not a suite in their team. So you don't know what their best practices are and how they're supposed to follow things. And they're probably not going to accept the code that you try to push in there. And then some of them don't like it when you're stepping on their toes. So then it's like, okay, fine, I won't mess with your code, just fix it. But then they're like, well, we don't have time. So it's frustrating because there are times when it's understandable and there are also times when it's not. Because there were definitely times where something wasn't a big impact, but it was an impact. And it went on for one time, it was like 8 or 9 months until they fixed it. And they admitted that it would have, because basically another incident that happened wasn't as drawn out in terms of the different levels, but it was drawn out in terms of time. So what it was is there was a segmentation issue, so to speak, which is just that the number of like listings that you have in your store is going to affect your performance. And the initial question was just, okay, I see there's very high tail latency here, right? Like if I'm looking at how long it takes for customers who are selling, who have a store, to process certain requests, it takes an extremely long time in that tail, in that like less than 1% of customers. It's like there were times I saw one time a request was like 10 minutes, and normally you measure it in like tens of milliseconds. So that was insane. And in this case, it's like it wasn't so much that there was a bug that needed to be fixed as much as observability that we needed to have. Because I needed to know, is this actually a problem? Like, who is being affected? And the SWE team immediately said that they're pretty sure it's a segmentation issue, as in there are different buckets of sellers and size. Like some of them have one listing or zero, others have literally millions. And so they just intuitively were like, well, it's probably only affecting the big sellers. But I wasn't satisfied with that. I wanted some more information there. And realistically, there was nothing exposed to the logs for us to be able to figure out how large these sellers were. So we can get all this latency, and the only way we could figure it out is if we manually searched for every single latency above a certain amount and then found the seller. And I did that. It took days. I manually cataloged a whole bunch of sellers and tried to put it in like an Excel sheet to figure out if there was some proportionality. And it was really kind of annoying because literally I talked to them, and we actually had several meetings, including with the entire team of our team with their team, and basically just discussed, okay, there's a single line basically that you have to add to your code to expose a new metric that basically defines a segmentable in the structured query, basically logql, that it can be segmented now on the size of the listings, basically the size of the seller, which reports basically the number of listings they have in their store. But that took forever. That took like 8 or 9 months until they did that. And they kept telling me in that case that it should only take a maximum of like 30 minutes for them to do it. But they would rather be in multiple 30-minute meetings with me every couple weeks to discuss how it'll only take 30 minutes to do it and how they're too busy to do it instead of just doing it. And I think this is kind of the case with everything, right? There are things when somebody does something wrong and it's for a good reason, and it's like, okay, that's fine. And there are other times they skipped in line because they tripped. And there's also the people that skipped in line because they wanted to skip, right? So that's basically the problem here, is that fundamentally the difference is hard to tell if they can do it and they don't want to, or if they don't have time to do it. And fundamentally what I really realized is that if the SRE organization is not part of their organization, there's actually no way that we can hold any software engineer accountable if they simply choose to not do what we suggest, because there's no authority that can say like, oh, you're going to be penalized, or I'm going to insert this into your sprint planning, because they have their own manager that manages that, and that manager doesn't necessarily care what we're doing. And that creates a negative environment where you basically are like, hey, Sweez, I need you to do something. And they're like, oh, great. Here comes a site reliability engineer going to make more work for us. And that's really because we're on the same team. Like that's like we're not literally on the same team, but we're on the same side. And I feel like the fact that we're not literally on the same team or department creates issues.
I think it's easy to forget that like SRE is essentially, in a lot of ways, an implementation of DevOps, and it's about bringing together development, delivery, and operations into a cohesive unit. So we don't have this divide which causes all these problems, and just that's not part of the core of what SRE is in an organization. It's going to be a big uphill battle. Well, we're almost at time, but is there any other things you wanted to cover before we close off today?
Sure. I think that it's important as an industry to understand the difference between SRE and DevOps because I definitely see a lot of times when I go to different, like SRECon or different sort of fairs and sort of things like that and conferences, a lot of people have this idea that SRE DevOps is identical and that it means that you're like a Kubernetes engineer and that's like all you do. It's like set up Kubernetes and Terraform and Ansible or like at a startup and constructing their entire infrastructure from the ground up yourself, which is weird because that's like an infrastructure engineer, that's like a system architect, that's a whole bunch of different things that as a startup could be rolled into one, but at a mature organization that has all their infrastructure put into place, you're not daily going to be interacting with Kubernetes, possibly ever, because your job is to understand the architecture as it is, understand how incidents might happen, understand how to mitigate, resolve them, and make that resolution permanent by talking to the suite teams and understanding how a resolution can be made and being that sort of bridge as like developer advocate, which is a very different skill set from like, hey, I'm the Terraform engineer. And I feel like that needs to be, I don't know if we need to spin off on yet another niche title or if there just needs to be a difference in sort of the industry, how we think about these things. But I feel like that's a big difference, which sometimes can make it difficult when you're trying to explain what you do when they're thinking Terraform engineer and you're thinking like root cause analysis expert, right?
Recently, I was looking at jobs posted for SRE, and most of them read like cloud infrastructure engineer in terms of what they were expecting of you. So thank you so much, Valeska, for coming back. I think this is a really fascinating story. We don't talk enough about the incidents that we go through and all the details of it and how complicated it is. I think most organizations of a certain scale are really complicated in a way that's very hard to articulate the complexity. We often hear at conferences from sort of smaller companies and tech companies who have maybe sort of like a unicorn status, but on the ground floor, on the real world, it's really challenging. And I love hearing stories like this. So thank you for sharing today.
Of course. Yeah, anytime. I definitely have a lot more to talk about, I would say.
And to everyone else, I hope you have a wonderful week, and I will see you all next time.